Hello and welcome to Easy Classroom. For today, we will be learning RS flip-flop. Now, from the earlier video that we have learned about SR flip-flop, the same thing we will be conducting, except the thing we will be using NOR gates, and over here we will be using AND gates. Now, what is AND gate and why we are using? The reason behind all these things is to separate the entire circuit when we don't want to use it. That is, the output of this kind of circuit should not be affected by any kind of signals that we don't want. Okay, so we are actually using AND gates over here. Why AND gates? Because this will actually allow us to filter what we want and what we don't want. Over here, what we are seeing is the NOR latch that we have learned. Okay. Now, what we are doing here, we will be counting all these things with the help of this QN. Okay. This S and R or R and S and this QN, because we have earlier known this is also the input and this is where we can get the output. Okay. Now, what would be the characteristic table or the truth table of this kind of system? Okay. So, for any given circuits, so for any given time, this AND gate will have the output as R dash and this will have S dash, or we can say R star or S star. So now what we are doing here, we are giving these inputs with this and we were trying to find the output signal. Okay. Now from here what we are going to do is we will put these things into consideration and we will try to find the output of this circuit. Okay. So first of all, what we say, what we give is this clock is 0. Okay. This clock is 0 and we will give the subsequent amount of the values to these pins. So this is 0, this is also 0 and this QN is also 0. Okay. So what happens? So this is AND gate. So the AND gate will actually pass the high output if both the pins are high for the AND gate. Okay. So if it is low, anything is low, any pin is low, the output will be low. So the R star will be 0 and this S star will also be 0 and this QN is 0. Okay. So this 0 and this 0, what will give? This will give 1 and this 1 and 0 will give a 0. So where from we are getting this? We are getting this from this circuit. So these are the NOR gates and this is the truth table of the NOR gate. Okay. So if these R and S, these two pins are 0 and this clock is 0, so the circuit will actually maintain its previous position and will not give out any other outputs. Okay. So whatever we will give, it will give the same thing. Okay. So what happens when the clock is 1? So when the clock is 1 and the S is 0, R is 0 and QN is also 0. So what happens? Okay. So the same thing happens. The S star is also 0, R star is also 0 and QN is 0. And if it does happens, that 0 and 0 will give me a 1 over here and this one will climb up here. So 0 and 1 will give me a 0. Okay. So when the clock is high and S and R are zeros and QN is also 0, so it will maintain the previous state, that is 0 state. What we are giving is what we are getting. Now, if we give the same thing with the QN is 1, QN is now high, what happens? So if the QN is 1, these two are 0. Here QN is only 1. This 1 and 0, we will get a 0 over here and this 0 will come up here. So 0 and 0, we will get a 1. Okay. So we see now if we have given 1 over here, we are getting 1. So if we are giving 0 at here, we are getting 0. So what we are giving is what we are getting. So we can say clearly this is a memory state or QN state. Okay. So now if we make this one, this R as 1 and S is 0 for this one only. Okay. So for this one, what will happen? Okay. So if receipt pin is 1, what will happen? This 1 and 1 will give me 1 and this S is 0 and QN is 0. So what will we get? So this 0 and this 0 we will get a 1 and this 1 and this 1 we will get a 0. So what we are giving is what if this R is 1 we will get a 0. So this circuit will actually perform this resetting condition. Now what will happen if just we change this input? So if this thing happens, so what is the output? So this 1 and this 0 we will get a 0 and this 0 and this 1 we will get a 0. Okay, so we see this thing get resetted. Now if we perform this as 1 and this next set, that is if this S is 1, what will happen? So this what will happen? So for this it is a 0 and for this it is a 1. Okay, and this is 0 for this row. What we are getting? So this 0 and this 1 we will get a 0 and this 0 and this 0 we will get a 1. So if the set pin is high, the output of this entire circuit will be actually set to 1. Okay. Now if we get this row, what will happen? So nothing changed, just this one is changed. Okay, so this one and this one we will get a 0 and this 0 and this 0 we will get a 1. So whatever the value, if the set pin is high, the output will also be a high. Okay, so we say this is a set state. Okay, so now what will happen to this one? So in cases like this, if both the pins are set to high, what will have the problem? This problem will be like this. It will confuse of what to take and what not to take, because these two pins are already high. So let us see what will happen. Actually in NOR latch, what we have referred to this 1 is of no use. So here also it will be having of no use. So let us consider. So this 1 and this 1, so R is 1, R dash is 1, S dash is 1 and A is 0. So what will happen? This 0 and this 1 will give me a 0 and this 0 and this 1 will also give me a 0. Okay. So what is happening over here? Why we are not taking it? Because this and this are same. So we cannot have the same value for two different pins. For the opposite pins, for complementary pins, we cannot have the same value. So we actually don't care. For this also, it is also don't care. We actually get 0 over here. So for this, if we give 1, what will happen? So this 1 and 1 we will get a 0 and this 0 and this 1 we will get a 0 again. So we see this and this does not have any complementary outputs. So we just say that this is a forbidden state, not used or forbidden. Okay. So from this table, if you want to draw the function table, how it will look. Okay. So what we have here is S, R, Qn plus 1. So this is 0, 0, 0, 1, 1, 0 and 1, 1. Okay. So for this it is Qn. Okay. The memory state. This is 0 or reset state. This is 1 or set state, and this is forbidden. Okay. So if we want to map it, to find the short method of drawing this type of circuit, as we have done in NAND latch, using NAND latch for a circuit. So now what we are having? We are having where there is Qn plus 1 is 1, we will be taking that particular thing. So here what we are getting? So from here what we are getting is S bar R bar Qn. Okay. So S bar R bar Qn is here. From here S R bar Qn bar. S R bar Qn bar. So here it is. For here this one S R bar Qn. This, and if we can complement these two also, we will take it as don't care. Okay, these two. So from the previous, if we keep this and keep this, so what we will get? So by doing this thing, what we will get? We will get from this, what we will get? We get this S plus, so Qn plus 1, what will have? S plus, okay, this one. So Qn dot this. So what is changing? S is changing to R complement. So this is a very good formula, and we can use it in drawing the simple form. Okay. So this is the block diagram, and we haven't discussed over here yet. So this is the block diagram. So R is here and S is here, and this is the actual circuit. R is here, it is here, and the clock pulse is here. So we are getting Qn and Qn complement. This is AND gate, or this is R, and this is S, and this is the output section. So this is Qn plus 1. So this is Qn, and this Qn is passing over here. So what we are getting is this. So this is the circuit, and if we want to get the excitation table from this, how we will get? So this is the excitation table, and we are getting here. So where we are getting, this is where we are getting, and this is where we are getting. So in these cases, what we see, R is changing, so we can straight away put cross, and this S is not changing, right? From this, R is changing, S is not changing, so we can put a 0 over here. So here 0, 1. So what is 0, 1? This is the particular set where is 0, 1. Okay. So S is 1, R is 0. Okay. So here, if 1 and 0, so where from we are getting 1 and 0? This is the only one we are getting, 1 and 0. So S is 0 and R is 1. Okay. And from this, where from we are getting this? 1 and 1. This from this and from this. We see R in both the cases are stable. So we put here 0, and this S is actually moving. It is changing, okay, from 1 to 0. This. So we can put across. Okay. So this is how we can draw excitation table from these kind of circuits. So I hope you have understood this thing. If you understood, please do like, share and subscribe. Thank you.